Life has always existed in one gravity. Everything else about the environment has changed, but 1G has always been a constant for 3.5 billion years. Well, if you take away 1G and you put them into microgravity, whether it's a plant or an animal cell, the cell kind of has never experienced this before. And so it doesn't really know what to do. And usually what a plant will do is if you stress it in a particular way, like you say you make it dry or you make it wet, it will turn on those genes in the genome that know how to deal with that, but it'll only turn those ones on. In microgravity, it's never experienced this before, so it turns everything on. All the old genome that's considered the junk DNA, all that turns on because it thinks, how do we deal with this threat, this perceived threat? So the survival mechanism of the plant stem cell turns on. And what that means is you get this differential gene expression where all of these genes that are normally dormant, they turn on. If all these genes are now turning on, why don't we stress the plant towards something we want it to do? And so what we've done is we have pushed the cell, now that it's differentiating, turning on all these genes, we now push it towards something we want it to do. Like, let's say we want it to grow in the cold. Well, let's make it cold and see what happens. And sure enough, in the Jatropha plant, which is a biodiesel fuel, 50 genes turned on, 50 genes plus, about 55 I think it was, that were already in the genome were cold-resistant genes. Now, this Jatropha, it's, as I say, it's a biofuel plant. It has a seed on it, a bit like an olive, and you squeeze it, out comes jet fuel. You only have to strain it, you don't have to do anything else. It's high-octane jet fuel. The plant is very robust. It will grow in dry, it will grow in wet, but it can't take the cold. So it has to grow in the tropics. So we thought, well, if we can extend its range so that perhaps it could grow in West Texas, for example, that would be very useful, very valuable. We've got a plant that not only produces 5 tons of jet fuel per hectare each year after it matures, it's also got many medicinal properties to it. It binds the soil, it's very good for the soil, it doesn't strip the soil. So it's a win-win for everybody. We're almost to the point now where we think we've got the plant that we can use and start planting in West Texas, where you might get a cold snap and it will be able to survive the cold snap, which previously it wouldn't be able to do. So that is the basis of the science we've been doing. And the key question a lot of people ask is this genetic modification? And we don't believe it is, because we're not adding or subtracting anything. We're not putting anything in that wasn't already there. We're just hybridizing it, which we've done as human beings for 15,000 years. And so this is not genetic modification. So we're just using microgravity as a tool to enhance and to also to speed up the process. All we're doing is we are getting the genome, this junk DNA, to just turn on the whole thing that goes back billions of years perhaps in its genome, to turn it all on and then say, okay, now that all these genes are actually not asleep, they're working, let's put it in an environment that we actually expose it to something that it knows how to deal with, but it didn't before. Now that all the genes are turned on and they're not asleep, now it's like, hey, we know how to deal with this, okay, fine, let's fix this. We're just using a new tool to create these new disease-resistant or strain-resistant or increased range tolerance of these crops.
Space.com